Okay, so we're looking at exercise 4E from the second year Stats and Mechanics textbook. So chapter 4 is on moments and exercise 4E is focusing on tilting. Okay, so we're looking at question 3. And we've got a plank of mass 12 kilograms, length of 3 meters. They haven't mentioned it being uniform, so always watch out for that. I think they actually do then bring that in later in the question. But so we can't just assume that the mass is working through the center of the rod until we give that information. Okay, so let's start drawing it out. So we've got AB. So there's my plank. It's supported at C, which is 0.7 meters from A, so we'll draw that about there. And DB, so D is about 1.1 meters from B, so let's do it about there. Okay, so it doesn't have to be completely to scale. Okay, and then we've got a boy is going to stand on the plank at E, and I don't know where E is. That's what the question is. And then it tells me that it's a uniform rod. So I know that this 12 kilograms is halfway along the rod. And if I know that is 1.1 meters, and that I think they said was 0.7, did they? Yeah. Okay, so halfway along the rod is going to be 0.5, so the center is between those two and a little bit closer to D. Okay, and the mass is 12 kilograms, so the weight is 12g. Okay, and then I've got the boy standing on the plank, and when he stands on the plank, it's about to tilt about D. So if it's going to tilt about D, it means that D will be the pivot. So the left-hand side is going to lift up away from C, and the right-hand side is going to turn down. So the whole thing will be turning clockwise. Okay, so if we think about it, for that to happen, this boy must be standing somewhere between D and B. Okay, I'm going to get rid of that measurement for now, just it's getting in the way a little bit. I'll relabel it if I need to. So he needs to be standing sort of somewhere about there, okay, because otherwise, and I know it's that end that's got to be going down because the left-hand side can't come down because support C is in the way. So if this beam is about to tilt about D, it must be that the left-hand side comes up. So this boy has a mass of 32 kilograms, so his weight is 32g, and there's going to be a reaction at D, but there's going to be no reaction force at C. So this is the main kind of point of this chapter, or this exercise, sorry, is that if it tells you it's about to tilt, so when it says it's about to tilt about D, it means D will be the pivot, so that's where it's tilting about, and it means it's just about to lift up at C. So it is still touching C, but it's just about to lift up, so there is no reaction force at C. Okay, so those are my only forces. I want the distance AE, so I want basically the distance of where the boy is stood from this end. So I'm going to do that by taking moments. I do know the reaction force. The reaction force is 44g, because if I resolve vertically, the upward force, that's the only upward force, so that must equal those two downward forces. But I'm not even going to use that because I'm going to take moments about D. That's not the only way of answering this question. You could take moments about A, because that's where they want the final answer to be measured from. The reason I'm going to take moments about D is I only then need to consider these two forces, whereas if I take moments about A, I'd need to include the moments caused by this force, and this force. Okay, but it works fine either way, but I'm going to take moments about D. Okay, so taking moments about D, I've got this force is going to be pushing the left-hand side down, so that's going to be trying to turn the whole thing anti-clockwise. So that's going to be a force of 12g times the distance. So we haven't done the distances yet. Right. So I know that D is, so they tell me in the question that D is 1.1 meters from B. So if the whole thing is 3 meters long, I know that that is 1.9 meters from A. Okay, just take away 1.1. I also know that because it's a uniform rod, the center of mass is 1.5 meters from A. So the distance I actually want, that distance there must be 0.4. Okay, so that's a force of 12g multiplied by a distance of 0.4. So that's going to be the only anti-clockwise moment, and that must equal the clockwise moment, which is going to be due to this force here. So that's a force of 32g, and I don't know this distance, so it's getting a bit clever there, right? I don't know this distance, I'm going to call that x. So it's a force of 32g times the distance of x. So let's cancel through by g to make it a little bit easier. 12 times 0.4, so 4.8 is 32x. So x is 4.8 over 32, so 3 over 20. Okay, and then I just need to be really careful because that's not my final answer. They want the distance. Let's find a nice colour we haven't used. Okay, so the question actually asked me for the distance AE. So that is that whole distance there. Well, I know that that was 1.9. I now know that that is 3 over 20. So AE is 1.9 plus 3 over 20. So 2.05 meters. Okay, and that seems okay because, yeah, that was 1.9, so it had to be more. Well, obviously it's going to be more than that because that's how I worked out, but seems okay in terms of the question. Let's just double check. Lovely.